Imagine building a skyscraper in one of the hottest regions on Earth without relying heavily on air conditioning. Sounds impossible, right? Now imagine that the inspiration for this building didn't come from architects, engineers, or scientists. It came from termites. Tiny insects, only a few millimeters long, may have solved one of architecture's biggest challenges, keeping buildings cool while using very little energy. And today, architects around the world are learning from them. This is the incredible story of how termites are helping us design the future of sustainable buildings. Welcome to Build It Sustainable. If you're interested in smarter homes, sustainable architecture, and practical design ideas inspired by nature, you're in the right place. Today we're exploring one of the most fascinating examples of biomimicry, the practice of learning from nature's solutions. And our teacher today? A tiny insect that has been building climate-controlled structures for millions of years. Let's start with a question. How do termites survive extreme temperatures? In many parts of Africa, daytime temperatures can exceed 40 degrees Celsius. Yet inside a termite mound, temperatures remain surprisingly stable. The colony needs a consistent environment because termites farm a fungus that is extremely sensitive to temperature changes. If temperatures fluctuate too much, the entire colony could collapse. So termites developed an incredible solution. Over millions of years, they evolved mound structures filled with tunnels, chambers, vents, and air pathways. These structures constantly regulate airflow. As outside temperatures change, air moves naturally through the mound. Warm air rises and escapes. Cooler air is drawn inward. The result is a remarkably stable internal climate, without electricity, without fans, without air conditioners. Nature solved passive climate control long before humans invented HVAC systems. For years, scientists studied termite mounds to understand how they worked. What they found fascinated architects. The mound wasn't simply a shelter, it was a living ventilation system. The structure continuously responded to temperature changes. Air flowed naturally through carefully designed channels. Heat was removed without consuming energy. And that's when architects began asking an important question. What if buildings could do the same thing? Instead of fighting nature with bigger air conditioners, what if buildings worked with nature? What if airflow became part of the design itself? That question led to one of the most famous examples of sustainable architecture in the world. In Harare, Zimbabwe, architect Mick Pierce designed a commercial building called Eastgate Center. The climate there is hot. Most buildings rely heavily on air conditioning. But Pierce wanted a different solution. Inspired by termite mounds, he designed a building that uses natural ventilation and thermal mass to regulate temperature. During the day, thick materials absorb heat. At night, cooler air flushes the building and removes stored heat. A carefully designed network of vents and air pathways helps air circulate naturally. The result? The building uses dramatically less energy for cooling than conventional buildings, and tenants benefit from lower operating costs. This project became one of the world's most famous examples of biomimicry in architecture, not because it copied the shape of a termite mound, but because it copied the way a termite mound works. That's an important distinction. Real biomimicry isn't about appearance, it's about function. Now you might be thinking, that's interesting for office buildings, but what does it mean for my home? Quite a lot, actually. Termites teach us several valuable lessons. Lesson 1. Air should move. Many modern homes trap heat. Poor ventilation causes hot air to build up indoors. Termite mounds remind us that airflow is essential. Cross-ventilation, strategically placed windows, and roof vents can dramatically improve comfort. Lesson 2. Use thermal mass wisely. Thick walls, stone, brick, and earth materials can absorb heat during the day and release it slowly later. Traditional architecture around the world has used this principle for centuries. Termites simply perfected it. Lesson 3. Work with climate. Nature doesn't fight the environment, it adapts to it. The best buildings do the same. Instead of forcing indoor conditions through constant mechanical cooling, sustainable homes take advantage of sunlight, shade, wind, and seasonal changes. Lesson 4. Design systems, not objects. A termite mound isn't just a structure, it's an ecosystem. Every part works together. Sustainable homes should follow the same principle. Ventilation, Insulation, orientation, shading, water management, and materials should all work as a connected system. The story of termite-inspired architecture reveals something bigger. For centuries, humans viewed nature as something to conquer, but nature has been solving engineering challenges for billions of years. Efficient cooling, resource management, structural resilience, waste reduction, energy conservation. Nature has already tested countless solutions, and many of those solutions are far more efficient than the systems we use today. The future of architecture may not come solely from new technology. It may come from paying closer attention to the natural world. The next time you see a termite mound, remember, you're looking at one of the most sophisticated climate control systems on Earth. Built without electricity, built without machines, built through millions of years of evolution, and its lessons are helping architects create cooler, smarter, and more sustainable buildings today. Because sometimes, the future isn't about inventing something completely new. Sometimes it's about learning from what nature has been doing all along. If you enjoyed this video, subscribe to Build It Sustainable for more ideas on sustainable homes, smart architecture, and nature-inspired design. And tell me in the comments, what other animal, plant, or natural system should architects learn from next? Thanks for watching, and I'll see you in the next video.